Hello. Well, school's almost starting, so I'm doing Chem again. I'm gonna do intermolecular forces, like a review kind of thing. I mean, I'm not that good at it, so. Oh well. First question: place the following order. Place the following in order from lowest boiling point to highest boiling point. Next to each, describe the form of attraction for the molecule. We have Ar02, S8, I2, HFCH4H2O. Why is there so many? H2OC, H22, H2S. So first, we want to find out the ones that put them into the different types of attractions. So we have HF, H2O, that are hydrogen bonds. And look at the rest. There's not really H2S. That's V-shaped, so that's dipole. Let's see the other ones. The other ones, and none of the other ones are actually dipoles. So first we have dispersion. So it says lowest boiling point to highest boiling point. Okay. Let's look at each of the dispersion ones. Okay, so these are only have dispersion. So if you have dispersion and you want to order them, you look at their what is it called? They look at their atomic mass, and let me see. So argon is 40. O2 is 16 times 2, 32. S8, let's just say S is 30, that makes it 240 something. And then I is 126, so 200. So wait, 200. So that's 250 around. And then CH4, H is 1, C is 12, so that's around 16. And C10, H22, so that's 120 plus 22, 142, I think. Yeah. Now we have to order them. So the lowest will be HCH4, and then it'll be O2, and then it's AR, and then it's C10H22, S8, I2. Yeah. Wait, S8, because because over 32, maybe it can go pretty high. Wait, 32 times 8. What about that? 32. Wait, it's 32 times 8. 240. 240 plus 16 is 256. Well, that's higher than iodine is 126.9, so 7. So that'll be 4. That makes sulfur higher, so okay, that's the order right now. And then now we're gonna do the ones that only have dipole, which there's only one, H2S. And then it's the 2 hydrogen bonds. So H2O is like that, yeah. So then with another H2O, it can go like there or there, so that's around like, and then you have hydrogens here. So that's like two at least hydrogen bonds with other water molecules, but HF, it can only go with like one more. So then water have a higher boiling point, so we do HF first and then H2O. That's the order. Oh well, now we go to second question. It's like explain in detail why carbon tetrachloride, the carbon tetrachloride does not dissolve in water but dissolves in hexane. Okay, so first we say carbon tetrachloride is non-polar, while water is polar with hexane being hexane yes, non-polar. For carbon, I'm sure I think it's simplified. In actual response, you should write longer than this. Carbon tetrachloride. For carbon tetrachloride to dissolve in water, it must disrupt the strong hydrogen bonds between water, which is very hard for a non-polar molecule, so carbon tetrachloride will not dissolve. Well, on the other hand, carbon tetrachloride and what's the other hexane will dissolve as they are both non-polar and can easily form new bonds with each other, as both of them have will have dispersion forces. Oh well, that's basically it for the response for this question. Oh well, bye bye.